Hello, I'm Praveen. This is my submission for probability homework 10. In the first question, we are asked to write about the Poisson process. So, a Poisson process is nothing but a stochastic process uh, where the occurrences of the events in a certain time interval, we consider time interval for a stochastic process. So the occurrences in the time interval follows uh, Poisson distribution. So we know that for Poisson distribution, uh, the number of occurrences in the time t is lambda t per k to e power minus lambda t by k factorial, where k is the number of occurrences and lambda is the mean. So here in Poisson process, we consider a time interval instead of single time. So the interval can be from t1 to t2 or from t3 to t4, etc. So one more interesting property is that in Poisson process, the if x of t is the Poisson process, then x of t1 comma t2, that is the occurrences in the interval t1 to t2, and for another Poisson process x of t3 t4. Suppose if t1 t2 t3 t4 the intervals do not overlap, then both the processes are independent. So, and also the time between occurrence of events, the successive events, also follows exponential distribution. That is why we have the this term here, e power minus lambda t. So that means that uh, if an event occurred and we are waiting for the next event to occur, uh, the time that we have been waiting for the next event to occur does not depend on whether the next event is supposed to occur. So the next event occurring is independent of the time we have been waiting for that event to occur. So another a type of Poisson process is the homogeneous Poisson process. It's a special case where uh, the number of occurrences in the interval of same duration, say t1 to t2 or t3 to t4, if the intervals are of equal time, the number of occurrences are the same. So suppose we consider a supermarket, the number of people coming to a supermarket, it is a non-homogeneous Poisson process, because for the same interval of time on a weekday, the number of people who come might be less than on a weekend. So the mean is lambda t. It's a linear function of time. So as the time increases, the number of occurrences increases, but the occurrences also follow exponential distribution. So this is the expression for a Poisson process. And a Poisson increment is nothing but the property of a Poisson process where we take non-overlapping intervals of time. We already discussed it in the first subdivision. So p of x t1 t2 equal to k is nothing but e power minus lambda t2 minus t1 lambda t2 minus t1 power k by k factorial. So these two processes they are independent as long as the time interval t1 to t2 and t3 to t4 don't overlap. So the next one is normal process. So a normal or Gaussian process is a type of stochastic process where the occurrences in time interval follow normal distribution. One more interesting property is that the nth order statistics of a Gaussian process can be derived or they are defined if only the second order statistics are known. So a Gaussian process also follows a Markov model. If a Gaussian process is wide sense stationary, it is also strict sense stationary, because wide sense stationary only considers up to the second order statistics, while the strict sense stationary is a more exhaustive and stringent stationary condition. So the distribution of Gaussian process is the joint distribution of random variables x t1 to tn for time t1 to tn. So many natural phenomena like Brownian motion, that is the random movement of molecules, particles in general, follow Brownian motion. So yeah, as the second order statistics completely defines Gaussian process, and if we have the covariance and we know that the mean is 0, so it's just nothing but we have a value for the second order statistics, then the Poisson process is completely the Gaussian process is completely defined. So why, thank you.